Hello everyone, how are you today? I hope you are in a great condition. We are from Group 1. My name is Arum Puspa Dahayu. My three last digit is 011. And my friend, Maylafayza Salsabila Zen, her three last digit is 003. You can see here guys, we're gonna talk about giant probability distribution for our project fulfillment in Introduction to Probability courses. Our sources is from well-known edition about probability and statistics. Okay, next we have definition 3.8. As you can see, the function f(x,y) is a giant probability distribution or probability mass function of the discrete random variable x and y if the following conditions are met. First, function of f(x,y) is positive or equals to 0 for all x, y. The second is the sum of f(x,y) over all possible values of x and y is equals to 1. And the third one is the probability that x equals to x and y equals to y is given by f(x,y). For any region A in the xy plane, the probability that xy element A is equals with the sum of fxy over all xy in A. Next, we are going to the examples. Here, a large box contains 11 cubes consisting of 4 red cubes, 3 white cubes, and 4 blue cubes. If 5 cubes are thrown randomly, A. What is the probability of throwing exactly 2 red cubes and 2 white cubes? B. What is the probability of throwing red-white cubes such that their total number does not exceed 3? Okay, we are gonna do the A question first. Let X is the probability of throwing red cubes and Y is the probability of throwing white cubes. First, we're gonna sum the totals of the cube. There is 4 red cubes plus 3 white cubes plus 4 blue cubes is equals with 11. Remember that the cubes we need to throw is 5 out of 11 cubes. So we will use the combination like this. We define like this. That means we will draw 5 out of 11 cubes. We put the formula of the combination, that is n factorial over r factorial n minus r factorial, like this. And we can scratch over here, and the result is 462. Then the question is want us to draw exact two red and two white. Since on the question want us to take 5 cubes, so the last cube will be blue. The combination formula is like that on here. We is to take 2 out of 4 red cubes. We use combination and the result is 6. And we do all over we need. And you can see the result there. Since it is a giant probability, that means that the event occurring simultaneously. So we need to find the product from condition 1, 2, and 3 before. The first is combination 2 out of 4 red cube times combination 2 out of 3 white cubes times combination 1 out of 4 blue cubes. The result is 72. Then we put it in this new formula to find the probability, and the result is 72 over 462. It is equals with 0.1558. So the probability of throwing exactly two red cubes and two white cubes is 72 over 462, or equals with 0.1558. Okay, go to B question. What is the probability of drawing red and white cubes such that their total number does not exceed 3? Okay, does not exceed 3 means that we can take 0 red cubes and 3 white cubes, or 1 red cubes and 2 white cubes, and so on, as long as the sum of the two cubes colors is no more than 3. Then we got a formula like this. X here means that the probability of throwing red cubes, or X, can be 0, 1, 2, 3, or 4. And same as Y there, Y means that the probability of throwing white cubes, so Y can be 0, 1, 2, or 3. Then the last one is the blue cubes. 5 minus x minus y. It means that the total cubes we want to draw is 5, and amount of blue cubes we'll draw is the difference between the two previous cubes' color. We will make a table to simply our job like this. So how supposed to use it? Nah, we have f 0.0, let x be 0 and y be 0. It means no red cubes drawn, no white cubes drawn, and 5 blue cubes will drawn. The result is 0. Why? Because you can see the blue cubes part. Because we cannot draw 5 blue cubes out of 4 blue cubes, right? So the result will be 0. Then we put it in here like this, and we have to another. Let x be 2 and y be 1. Here the result is 108 over 462. We can put the result here. Then we will do the same for all of the probability cubes drawn. If we have done find all the probability, it will be like this. And back to the question, what is the probability of drawing red and white cube such that their total number does not exceed 3? You can see the yellow mark here. Then we only need to sum all of the yellow mark, because it means that the red and white cube does not exceed 3. Like this. Yeah, if we have done to sum it, the result will be 303 over 462, or it is equals to 0.6558.
The next is definition 3.9. The function f(x, y) is a joint density function of the continuous random variable x and y if the first is f(x, y) is bigger than equal to 0 for all x, y. The second is the integral of negative infinity to infinity of integral in negative infinity to infinity f(x, y) dx dy equal 1, and the last is probability of x comma y element a equal to integral of integral a f x comma y dx dy for any region a in the xy plane. Okay, let's discuss with the question. A privately owned business operates both of a drive-in facility and a walk-in facility. On a randomly selected day, let X and Y respectively be the proportion of the time that the drive-in and the walk-in facilities are in use. And suppose the joint density function of this random variable is like this. And the question are, the first is the verify condition 2 of the definition 3.9, and the second is find probability of x comma y element a, where a is equal x comma y for x bigger than 0 and less than a half, and y bigger than 1 over 4 and less than a half. Okay, next is solution for A, verify condition 2 of definition 3.9. The integration of x comma y over the whole region is the integration of negative infinity to infinity of integration of negative infinity to infinity f x comma y dx dy. So the equal integration of 0 up to 1 of integration of 0 up to 1 2 over 5 times 2x plus dy dx and dy. So the first we will integrate with respect to the x. So the result is integration of 0 up to 1 times 2x squared over 5 times 6xy over 5 for x equals 0 up to x equal 1 dy. And then we substitute x comma 0 until x comma 1, and we found equal integration of 0 up to 1 times 2 over 5 plus n 6y over 5 dy. Next we will integrate with respect to the y, and the result is 2y over 5 times 2y squared over 5 for y equals 0 up to 1, and we substitute this and we found the result is 2 over 5 times 3 over 5 is equal 1. So the integration of fx comma y is 1. So this is the same as the condition 2 of the definition in the 3.9. Okay, so next is the solution for B. So to calculate the probability, we use the same formula like problem A. So the P probability of x comma y element A equal to P for x bigger than 0 and less than a half, and y bigger than 1 over 4 less than a half. So it is equal integration of 1 over 4 up to a half of integration of 0 up to a half for 2 over 5 times 2x plus dy dx dy. So the first we will integrate with respect to the x. So we found the result is integration of 1 over 4 up to a half times 2x squared over 5 times 6xy over 5 for x equal 0 until x equal a half dy. So we substitute x comma 0 and to x comma a half, and we found is this integral of 1 over 4 up to a half times 1 over 10 plus 3y over 5 dy. Then we will integrate with respect to the y, and we found y over 10 plus 3y squared over 10 for y equal 1 over 4 up to y over a half. Then we will substitute y over 1 over 4 until a half. Okay, and then the result is 1 over 10 times the bracket of a half plus 3 over 4 minus the bracket of 1 over 4 times 3 over 16, and the result is 13 over 116. Thus the probability is 13 over 160. Okay, so the next is definition 3.10. The marginal distribution of x alone and of y alone are gx equal the sum of y fx comma y and hy equal the sum of x fx comma y for the discrete case, and gx equal the integration of negative infinity to infinity fx comma y dy, and hy equal the integration of negative infinity to infinity fx comma y dx for the continuous case. Okay, so to better understand, I have the problem that we will work on together. So the question is find gx and hy for the joint density function of light in the screen. Okay, so let's discuss it. Okay, so the solution by definition, we find gx equal integration of negative infinity to infinity fx comma y dy. So we can substitute it and we find integration of 0 up to 1 for 2 over 5 times 2x plus 3y dy. So we will integrate with respect to the y, and the result is y over 10 plus 3y squared over 10 for y equals 0 up to y equal 1. So we can substitute it, and the result is 4x plus 3 over 5. And the next for hy, by also with the definition, we find integration of negative infinity to infinity fx comma y dx. So we substitute it, and the result is the integration of 0 up to 1 for 2 over 5 2x plus 3y dx. So we will integrate it with respect to the x, and the result is 2 times 1 plus 3y over 5. Okay, so the next is the last definition 3.11, and it said that let x and y be two random variables, discrete and continuous. Then the conditional distribution of the random variable y given that x equal x is f y given that x equal fx comma y over gx, provide that the gx bigger than 0. Similarly, the conditional distribution of x given that y equal y is fx given y equal fx comma y over hy, provided hy bigger than 0. Okay, to better understand, we will work on the problem on the screen. So the problem is two ball pens are selected at random from a box that contains 3 blue pens, 2 red pens, and 3 green pens. If x is the number of blue pens selected and y is the number of red pens selected, find the conditional distribution of x given that y equal 1 and use it to determine the probability of x comma 0 given that y equal 1. Okay, so in here we need to find f x given y where y equal 1. So the first we find that h1, so by the definition is the sum of x comma 0 up to 2 for fx comma y. So we calculate this and find the result is 3 over 7. So the next we will find the fx given 1. So by the definition is fx comma y over h1. So the general formula is combination of 7 and 3 fx comma 1 for x equals 0, 1, and 2. So for f0 given 1, we will calculate this and find the result is a half. And for f1 given 1, we calculate this and we found the result is a half. And for f2 given 1, the result is 0. So, and the conditional distribution of x given that y equal 1 is like in this table. And finally, the probability of x equal 0 for y equal 1 is f 0 given 1 is a half. Therefore, if it is known that the one of the two pen refills selected is red, we have the probability equal to a half that the other refill is not blue. Alright, that's all from us. We hope this can be understood well. Thank you for your listening. Hope it is useful. See you in the next topic and have a nice day. Bye bye.